So hello everyone, this is lecture 29 for the mathematical physics. In the last lecture I have given you this question. Okay, so we were discussing the non-homogeneous equations and there was this Rx function and we were trying to solve the equation for the different values of Rx and we were having the two solutions, that is homogeneous and the particular solution. So in the last lecture we discussed about the particular solution only. Now in today's lecture we will take an example, take one or two example and we will write the complete general solution. So first let's solve this question. This was d square minus 5d plus 6 exponential cos 2x. So this will go to the left hand side. After taking 1 inside this, d plus 1 square minus 5d plus 1 plus 6 cos 2x. Now you know how to solve this kind of equation. Means after solving this, in place of d square it will be minus a square. A is 2 here, so it will be minus 4 plus 2, it will give you minus 2, so minus 3d minus 2. So you will get something like this. Now take the minus 3 common and you will get this kind of form. This is 1 upon d plus a cos 2x, or you can say whole is 5x. So either you can use the direct this formula, this one, d plus a 5x, and you can use direct formula. Otherwise you can solve it like this also. Means you can do d minus 2 upon 3, d minus 2 upon 3, multiply and divide. So in the denominator you will get d square minus 4 by 9, and the numerator you will get this. Now in place of d square again you will replace it with minus a square, that will be minus 4, and just this will operate on this, so this will go with d and differentiate this, and minus 2 by 3 cos 2x. So that's how you can get the solution, or you can use that formula, again you will get the same solution. So you will have the same solution always. This will be your solution. Now let's write the complete solution for this question. Y double dash plus 2y dash plus 101y equal to 10.4 exponential x. So initial conditions are given, y 0 equal to 1.1, y dash 0 equal to minus 0.9. So these will be applicable only on the complete solution when you write the homogeneous plus particular solution. Only after that you can means place these initial values inside the equation. So let's find the complete solution. For that, first we need to find the homogeneous solution. So put this equal to 0, so it will be y double dash 2y dash plus 101y equal to 0. So this is a homogeneous equation with constant coefficients. So it will be lambda square plus 2 lambda plus 101 equal to 0. Find the value of lambda. It will give you minus 1 plus minus tan I. So it is a third kind, we already discussed. This is alpha plus minus beta I. So alpha will be minus 1 and beta will be tan. So solution will be exponential alpha x c1 cos beta x plus c2 sin beta x. So this is your solution, homogeneous solution. Now for the particular solution, use this, and 1 upon fd is d square plus 2d plus 101, and this 10.4 exponential x. So it is in the form of e to the power ax. So replace d with a. So a is 1 here, so we will replace here and we will solve this. You will get 0.1 exponential x. So this will be your particular solution and this will be your homogeneous solution. Now sum of these two will be your general solution, and we will use these conditions on them to find the C1 and C2 now. So complete solution will be this, homogeneous plus particular. So this will be your solution. Now find out the y dash x. So we'll just use the product rule. First differentiate this, then write it as it is, then differentiate this whole equation, write it as it is, and differentiation of this will give you same value. Now substitute these values. At 0 y dash is minus 0.9, and at x equal to 0 we have y equal to 1.1. So after solving this you will get the values of c1 and c2. Just place the values, it's a simple mathematics. And c1 c2 will be, c1 will be 1, c2 will be 0. So just put them in this equation, and you will have your solution. Now let's see one more example. Y double dash plus 2y dash plus y equal to exponential minus x. So homogeneous solution will be, put this equal to 0, and it will be constant coefficients. So again lambda square plus 2 lambda plus 1 equal to 0. So lambda will be same, so homogeneous solution will be this kind. So we have homogeneous solution. For particle solution, it is in the form of exponential ax. So ypx will be 1 upon fd is d square plus 2d plus 1. Exponential alpha x means ax. So replace d with a, so we will get minus 1 square this will be minus 2 plus 1, so you will get this is equal to 0. So we need to differentiate again. So x multiply 1 upon f dash d, so it will be 2d plus 2. Now replace it minus 1, again we are getting 0, so let's take differentiation again. So x square, this will give you 2, and this, so this will be your particular solution. Add this and this will be your complete solution, and using these conditions you can find the c1 and c2. Try to solve, you will get c1 is equal to minus 1, c2 equal to 0. Now let's take one more example. Y double dash plus 2y dash plus 5y equal to this plus this plus this. Okay, 1.25 exponential 0.5x, 40 cos 4x minus 55 sin 4x, and this is plus here. So first find the homogeneous solution, put whole this term equal to 0. So this will be our again coefficient constant coefficient equation. So lambda square plus 2 lambda plus 5, find the value of lambda. Then you have alpha and beta, alpha is minus 1, beta is this. So you have solution will be like this: e to the alpha x, c1 cos beta x, c2 cos sin beta x. Now for particular solution, 1 upon fd, fd is this, d square plus 2d plus 5, and this whole term. Now distribute them with this separately. So with this you will place in place of d 0.5, with this you will see, let's, for this you will have 0.5 in the here, and you will get this solution. Now for this second term, we know in place of d square we can replace with minus a square, that will be minus 16. So minus 16 plus 5, 4 4 16, so it will give you minus 11. So what you will do when you will get this, then you will again use the formula I told you, 1 upon d plus a cos means 1 upon d plus a phi x. So use that formula, or you can just use the thing d plus a d minus a, divide and multiply, and in denominator you will again get d square, then you will replace that, and the above operator will be operate on the directly, and you will get this solution. Okay, so same for this, same apply for this, you can directly solve. Means first in place of d square you will write minus a square, so it will be minus 4 4 16, so minus 16 plus 5, it will give you minus 11, 2d minus 11. Now you can replace this with 2d plus 11, 2d plus 11, so you will just get your answer. So this will be your solution. Again, you know how to solve this kind of equation, we already discussed many examples related to this. Okay, so you will get this solution. Let's move forward. So after that you will write the sum of homogeneous and the particular solution, and find the value of c1 c2. You will get c2 equal to 20, c1 equal to 0. Okay, so let's see one more example. This is y double dash minus y, this is 2 cos st, this is hyperbolic function, okay, for the cosine. So for the homogeneous solution you will have constant coefficients, and lambda square minus 1 equal to 0, lambda will be plus minus 1, so this will be your solution in terms of t, because here we have t. Now the for the particular solution you will have 1 upon fd, 2 cos st. So this hyperbolic function can be written as exponential t plus exponential minus t divided by 2. 2 will 2 cancel out, you will get this. Now you know how to find the solution of this. Separately use this first, then this first, then this will give you 1t, so 1 you will place, it will give you 0 here, and this will also give you 0 here. So you need to take the differentiation again for this, so it will give you 2d. Okay, so first we divide this in these two, then this is giving 0 here because of 1 putting downside, so we will differentiate 2d, and it will again 2d, and when we will it will t here, so 1 will give you 2 into 1 2, so you will get this solution. You know how to solve this, it's very easy. So after, if then we will combine these solutions and use the conditions, find the value of c1 c2, it will be 0 0. So try to solve. Let's discuss the last thing in the differential equations, that is again Euler's Cauchy form. We discussed the Euler Cauchy form in the previous lectures when this was 0, means that was homogeneous Euler Cauchy form. Now if we are having something like this, means it is non-homogeneous, then how to solve? So we know if we put x equal to exponential z, we do this for the Euler Cauchy form, then this whole equation turn out to be this. Means first this y is function of x here, but when we place x equal to exponential z and solve this, so we will get this equation, and here y is function of z. Okay, so let's substitute x equal to exponential z here, and we were getting this form. Remember from here. Means this was our equation. When we put the x equal to exponential z, we reduced this equation to this form: d square plus a minus 1 d plus b y equal to 0. Or this was your form, and here y was the function of z. Okay, then we know how to find the solution of this equation. We find the solution, and the last we just substitute in place of z, we put log x. So that was the Euler's form. Now here also we will do the same. We will substitute exponential z, then this will reduce to this, and this right hand side was 0, that place. So here it will be exponential z will be exponential zm. Okay, and here y is the function of z now. Okay. So now the solution of this equation you can find. How? We already discussed many examples. This is a simple constant coefficient homogeneous equation, and this is Rx is exponential terms. So solution will be homogeneous plus particular. So homogeneous will be, put this equal to 0. So let's see one example. This is our Euler's Cauchy form. So put exponential z. So here it will be exponential 4z. In the left hand side we will get this form. Here this is a minus 1. So a is minus 2. Minus 2 minus 1 is minus 3. Minus 4y equal to this. Now solve this for the homogeneous solution. So lambda square minus 3 lambda minus 4 equal to 0. Lambda will be minus 1 4. So you will get the homogeneous solution. Now for the particle solution, it will be 1 upon fd. Fd is from here. Fd is d square minus 3d minus 4 exponential 4z. So substitute 4 in place of d. So you will get 4 4 is 16, and it will give you 12 and 12. So it will give you 0. So you need to differentiate it again. So z multiply 1 upon f dash d. So 2d minus 3. Now put the 4 here. So 4 is 8 3 5. So now this will be your particle solution. So complete solution will be homogeneous solution plus particle solution. Now this is your solution in terms of z. Now replace z with log x, because log x will give you z. So z is log x. So replace z with log x. It will give you x to the power minus 1 here, because it will be minus log x. So it will be log x to the power minus 1. It will give you exponential log x is x. So that's why we are getting this. Here also it will give you x4 when you put log x here. When we put log x here, it will give you x4 again, and z is log x here. So this will be your solution for this kind of form. So here our differential equation series ends. Okay, from the next lecture we will start the complex analysis. So revise this. This is very important section from the exam point of view. Thank you everyone.